Hi- Hello, everyone. Okay, so now this is section 5.4. Now this section is about definite integral. All right, so far on this chapter 5, we will learn about indefinite integral. So indefinite integral, we said something like this, right? We said this is indefinite integral. So now on definite integral, uh, well, we need to work with an intervals. All right, so let me show you the idea here. So let's say there is a graph, and this is f of x function graph. All right, and let's say um, we have an interval a to b. Okay, and let's say uh, just give me a moment. Okay, yeah, let's say um, this area is a, and this area is b. Okay, now introducing when you introduce this definite integral, the definite integrals work with intervals. So if I say the integration sign like this, and here a and here b, so that means we're taking the integration from a to b, so from this point to this point. So when I say something like this, I'm taking the area of uh, these regions between these intervals. So from this point to this point, you need to consider this area, and from this point to this point, consider this area. But when you take the integration, as I said, it's going to be area, right? Area enclosed by the graph, the area enclosed by the graph with x-axis, because I have x here. That's why with x-axis. But the thing is, the area above x-axis, so this area will be positive area, and this area below x-axis will be negative area. All right, so that means if I'm taking the integration of this graph or this function, then it will be, of course, like I said, area, right? But since this area is below the x-axis, so it will be negative a, and this is above x-axis, so it will be positive b. So this is how we take the integration, or this is called definite integral. All right, so this is the idea of the definite integral. Okay, now let's do an example. Okay, so again, let's say we have a graph. Now we have few intervals. So we have a to b. So this interval include this area. Let's say this area is a, which is below x-axis, right? This is x-axis, this is y-axis. And this area is, let's say this whole area from B to C is capital B, and from C to D is capital C. All right, and the value of these area are given. So area of A is 2.12, area B is 11.9, and area of C is 7.67. So these are given. Okay, now I need to find the integration of f of x dx from, so this means from A to B. All right, so from A to B, the area is this. But since it is below x-axis, so the area is going to be negative 2.12. Okay. Similarly, from B to C, well, from B to C, we have two things. One is, well, there is an area enclosed uh, to x-axis, but this area is above x-axis, right? So this area will be positive, right? So that means it will be positive 11.9. From B to C, we're looking from B. Oh, no, from B to C, sorry. From B to C, it's just from this point to this point. Yeah, from this point to this point. So that's it. It's going to be positive 11.9, right? Now for B to D, it's different. Yeah. For B to D, so from B to D, we have two intervals, right? From B to C and C to D. So first B to C. So here we have to consider two integrations. So for B to D, first we have to look B to C of x dx, and then C to D, f of x dx, right? So for B to C, it's area B, which is 11.9, and it is also above x-axis, so it will be positive. For C to D, the integration from C to D is below x-axis, so it will be negative, so negative 7.67. So this will give 4.23. Yeah, 4.23. Okay, so yeah, this is the idea. All right, so let me do another, or let's first look at the property and then we'll look the example. So here on the definite integral, the property, well, since now we're looking at the interval right now, if you're taking the integration from a to a of f of x dx, means the value is of course 0, right? Because if you're looking the integration, let's say of something, let's say this is a, from a to a means, well, there is no area, right? So it's not moving. Like I said, it's, like I said here, this means the area, right? So there is no area, right? That's why there is 0. Now, similarly, if I say integration from a to b of f of x dx, I can also say this is negative. And if I say negative, this a to b will be b to a. All right. Similarly here, if k is a constant, then I can bring that out, just like we did on the indefinite integral, right? And this is also same as indefinite integral. So if you have two function adding or subtracting to each other, then I can split this into two integrals like this. Okay, and also this one here, if we have integral from a to c, then we can also say this as well. Let's say if we have so this is a, this is c. All right, so I'm trying to find the integration from a to c. This is also same as a to b plus b to c, right? We have two integrations. So this means if b is in between these two intervals, so let's say b can be anywhere, let's say b is somewhere down here, then this is same as, right? This is same as the integration of f of x dx from a to b, right? From a to b plus b to c, integration of f of x dx from b to c, right? Simple idea, right? Okay, now let's do an example. So all of these are given, all right? So here, integration from 1 to 4, x dx, let's say the value is 3. Similarly, for this one, x squared dx, value is 5. And for this one, the integration, now it's different, right? From 4 to 5, x squared dx is 8. Now we need to find the value of integration from 1 to 4 of 2x dx, then, well, I can here basically just bring this 2 out. So I'll just have integration from 1 to 4 of x dx, right? So the value of this is given, right, from 1 to 4x dx, the value is 3, right? So that means 2 times 3 is 6, right? So integration from 4 to 5 of 6x squared dx is, well, again, I can take that out, for 5x squared dx. Now, well, the value of this is given 8 right here. So 8 times 6 is 48. Similarly, let's say from 1 to 4 of 5x plus x squared dx is same as, I can also say this is same as integration from 1 to 4 of 5x dx, right? Plus integration from 1 to 4 x squared dx, right? So if I bring this 5 out, we get the integration, well, we just have integration of x dx from 1 to 4, which is 5. Again, that value is also 5, right? Times 5. Plus this one is given, which is 3. Okay, so 5 plus 5, 5 times 5 is 25. 25 times 3 is 28. Right? So yeah. So on this section, it is basically the introduction of indefinite intervals. So this chapter is all about the idea of the indefinite integral. All right. So I did, yeah, I showed all of these things to just give an idea of what does the definite integral means. So now on the next chapter, I will or we'll be doing few problems of definite integral. Okay. And yeah, this video is a very short video. All right. So I'll see you in the next one. All right. Thank you.